Assalamualaikum and good day everyone. My name is Mohamad Nursyahmi from 4SMJM will presenting about my final year project titled Effect of Fabrication Method on Magnetostrictive of Magnetorheological Form. This research was supervised and guided by Dr. Nur Azmah binti Nordin. Nowadays, sensor technology has been widely used in electrical appliances to ease of humans' daily life. Modernization of the global technologies has forced the world towards the IR 4.0, which focuses on high technology sensors and devices. Magnetorheological or MR form is one of advanced materials that can be changed continuously, actively, and reversibly upon applied magnetic field. It consists of magnetic particles of carbonyl ion or CIPs that are attached or embedded in the form of a matrix that possesses the behavior of magnetostrictive. But what is the relationship or connection between magnetorheological and magnetostrictive? Actually, magnetostrictive is a branch of magnetorheological mechanism. Magnetorheological means that magnetic field have ability to alter their main structure. The structure of magnetostrictive material also altered when magnetic field was applied toward them, but only associated with deformation specified at normal strain. A relationship or connection between them produce a kind of behavior that can change its dimension either in macro to micro scale depending on the strength of the magnetic field. However, different fabrication processes of MR form, either in situ or ex situ methods, will result in different magnetostrictive effects, depending on the positions of magnetic particles in the structure of foam. Besides, different positions of embedded magnetic particles in the foam structure, either in the pores or inside the strut of foam pores, will give an idea to combine both fabrication methods. This combination route is known as a hybrid method that will drive two different magnetostrictive effects as compared to in situ or ex situ methods. Nevertheless, the exact findings are still unknown and need to be investigated in order to validate the hypothesis. The main objectives of the research are to characterize the structure, analyze the corresponding magnetostrictive effects respective to different input parameters, and evaluate the comparison magnetostrictive effect of each MR form fabricated via in situ, ex situ, and hybrid method. There are two steps that must be taken for the methodology part. Firstly, the MR form must be fabricated via in situ, ex situ, and hybrid fabrication method simultaneously. Basically, the substances required to perform all fabrication methods mentioned previously include polyol, isocyanate, CIPs, and MR fluid mixture. After that, we can proceed to perform the magnetostrictive testing. So let's start with fabrication stage first. As you can see here, the procedures for each fabrication methods are different. In situ method involves the integration or internal mixing of magnetic particles of CIPs with the absorbent matrix components such as foam for this research through combining the polyol with CIPs first before mixing with isocyanate that have ability to act as forming agent. Meanwhile, for ex situ method, each step of procedure can be simplified as externally soaking and squeezing simultaneously the ready form into MR fluid mixture while repeating measure the weight of that form several times until it reach a saturation stage. Lastly, for hybrid method, as it is combination of in situ and ex situ method, the step of this method begins with fabricating the in situ MR form first before externally soaking and squeezing simultaneously the in situ MR form into MR fluid mixture until it reach a saturation stage like ex situ method. After the fabrication stage was done, each samples must undergo the magnetostrictive test using rheometer device in order to investigate their normal strains when undergoing normal force application. Rheometer device was chosen as it have ability to measure stress, strain, and strain rate in broad range. The software used to control the rheometer device is ReoCompass due to the connection between the computer system and rheometer device. The main components that play important role in magnetostrictive tests are geometry and air bearing, as each of them have ability to measure normal force and allow the flowing of magnetic fields to ensure that the sample elongates respectively. So that's all from me. Thank you very much for your attention and have a nice day.